I'm here today. My name is Yash, and I'm doing a bit of a silly presentation, I think. Uh, fun story. I got invited, I think like maybe 4 days ago, to fill in for someone that dropped out. And in those 4 days, they were like, "Well, please send us a proposal." I was like, "Oh God, what am I gonna do? What should I do?" I wanted to do something a bit no. Oh, it's not working. Yeah, sure, sure. Okay, so we're having a bit of audio visual technical problems, so I'm like just gonna reconnect and keep talking. But I had to like do a proposal, and I was like, I want to do something really really silly. Um, so yes. So my talk today is how to build a whole stack from scratch in about 40 minutes. Um, I actually started coding this up today, and I managed to pull it off. I have it like all working, but I'm gonna try and like do it here again and walk you through the process and all the considerations and all the things you like need to know. So I'm also calling it sort of like millennial JS because us millennials are kind of like known for, oh, you use frameworks for everything. And I'm like, well. I guess we're just gonna make good frameworks now. So hey, live up to it. Hello, Verona. I'm Yash. I work at a little thingy called the DAP project. We built distributed system things for researchers. It's kind of interesting. You might know some of my coworkers, but yep, that's me. So we're gonna write 3 frameworks today. Yes, actually. So the idea is, well, actually it's more like 2.5 frameworks. The idea is we're going to build a backend framework, we're going to build a front-end framework, and we're going to build a little build tool chain to like create some HTML, CSS, and like serve it up to disk and system. So front-end app. Actually, I didn't get to like finish this. I just like finished my things. But the idea was to create an app that you can have a little input field. You like type in stuff and like updates a little thing, like two-way binding thingy, and then you hit save and like sends a request to the server and like it saves it in a database somewhere. So the constraints for this is like 60 FPS. You want to have some routes. You want to do like event emitting thing. You want to have like unidirectional rendering. You want to have like declarative DOM stuff, which is nice. So the backend. Oh, if you don't know what those terms mean, I'll go through them in a bit. So no worries. The backend app, I wanted to be like validate some content and save to a database. In the end, I didn't do the validation part, but it saves stuff to a database. Has like a little REST API thingy. It's kind of cool. Also, so request routing, validating of envars because we like to like have strong guarantees for environment, and some logging because logging is very important. We should not forget about it. Yeah, build system. So the build framework serve HTML, CSS, JavaScript over HTTP, and be able to also write it to disk because it's very important. Once you deploy, you don't like need to have your server. You need to actually write it to file system. So guess here goes. So who have you seen this code before? Yes, most people. Nice. Okay, so this is probably like my favorite little Node example because this is how you like write an HTTP server, and it's actually on the front page of Node, of nodejs.com, I think. But this is basically what I deal with whenever I like write anything, because this allows you to create a live reloading server if you like, or be like, oh, I'm gonna write like a REST API, or like gonna write some very complicated thing. This is the core of it. What happens here is you require HTTP. You say HTTP create server, and every time a request comes, and then you say server.listen on a certain port. And whenever like a request hits that port, it calls the callback with request and response. And then you can do response.end to like end it and send some data back. And you can stream into it. You can do heaps of stuff with this, but this is the basics. Now if we were like gonna create some HTML, there's a really cool module on NPM. It's called create HTML. You know what? I'm just gonna type this out. Hey. So I have like done these things already before. Let me see. What do I want to do? Okay. Here's the thing we're gonna do. I have about 40 minutes to do this thing. So I'm gonna type out as much as I can. I'm gonna explain as much as I can. At some point, I'm gonna be like, I guess we like need to move on, and I'll like show you the finished example. All right? Okay. I've not done this talk before. Again, it's kind of silly. 3 frameworks in one talk? Yeah, sure. Um, so let's say this is gonna be our, what are we doing? What are we doing? Build.js, right? So we have build.js, we go into build.js, and we're like, cool. We need to create some HTML. So there's this cool little module called create HTML. And if we call it, it creates us some HTML. So we're going to paste that in here. And we're going to say node build.js. And then out pops some HTML, right? There in the bottom left corner. Can everyone see this in the back, by the way? Is it good? Thumbs up? Cool. Sweet. Cool. And I'm just going to keep it like this. So if you like want to do some HTML, you don't want to like remember the whole boilerplate template thing, just use that module. It's kind of useful. Okay, next step. Browserify for JavaScript. So if you like want to compile JavaScript, like get all those require files together and like put them into like a single thing, then Browserify does exactly that and nothing more. That's all it does. It provides that and a way to hook into those require statements. So well, let's copy that one too. Why not? So this file here now says here's a console that create some HTML, console.log it out, and then browserify app.js and bundle it and output it to standard out. So this requires us to create app.js because else it will fail. Let's open app.js, console.log, hey. So it's a pretty empty file right now, right? Let's see what it does. So if we say node build.js, first it outputs all the HTML, then browserify hits in and does a whole bunch of bundling, and it all just like dumps it to standard out. Not too interesting, right? Cool. Next one. You might not know this one. This is one of my own creations. The other ones I haven't made. It's called Sheetify. It allows us to do CSS in JavaScript, but we factor it out at compile time, so it has no overhead. Some people might be like, oh, but that's kind of gross. Why would you do that? I'm like, well, we don't want to like push the cost of us wanting to like write CSS and JavaScript to the end users. We want to give them like the best possible experience. But this is a way to like make it so we can get like static CSS files. I'm not going to do the last part of getting it out of the JavaScript, but this allows you to do it. Syntax kind of looks like this if you were to use it in your front-end JavaScript. Require Sheetify. Sorry, I forgot. I typed that one up. But then you say CSS template string some classes, which are global styles. You can reference the shadow DOM : host selector to get a unique hex prefix, which is then like a how do you call that? Namespace classes, so they don't conflict. And you can also call it as a normal function to require CSS from npm. So if a package JSON file has a style tag, then Sheetify will pick that up and put it inside of your build, which is kind of neat. So the way you use it is you just add browserify transform Sheetify to your thing. Let's see, there, right? No, here. So I've already installed all the dependencies in case you're wondering, oh, B was used before it's done. Cool, fine, let's use it there. So I'm also using standard, by the way, which is super useful. Right, so now we can like write CSS in a thing. Let's check if it still works. Node build.js. Cool, we're not requiring any CSS. Oh, you know what? Let's require some CSS. So var CSS is require Sheetify, require Sheetify. I should work on my autocomplete. CSS tachyons or something. Let's do npm link tachyons. No, npc tachyon. Let's install tachyons. I'm not on the internet right now, so this is my offline command that I've like created, which is kind of cool. Now let's run this again. Node build.js. And there you see like a whole bunch of like code going on and styles, and it's all like inline, and we have CSS now inside of our JavaScript. Cool. So you've seen this. Cool. Now we want to have like 2 separate commands for our build system. We want to have a start command, which is like HTTP server, and we want to have a build command, which writes to disk. So we split on process argv2. Our process argv is an array, and the second argument, the first one is generally, I forgot what it is, but the second argument is always the command you want to have. So here we just require people like put in a command. So just for fun, let's put this at the top. And then we say node build.js, and it says, oops, we only support build and start. So that's expected. That's cool. So let's say we want to put our requires at the top, right? Like that. Then we have like a few things going on in there. Let's copy, oh, oops, I deleted some files. Let's copy this and put it in there, because this is kind of cool. And then let's move this code in there, because that's kind of cool. So now all it does is still push the standard out. So that's not good. So let's do the start command first, right? So we already had like the, if we go back to this slide, HTTP. We're just going to write a little HTTP server here. So var HTTP is require HTTP. I'm kind of like keeping track on time so I don't like overdo it. I'll like, hey. But also my throat is a bit itchy. var server is HTTP create. Why am I typing this even? We just do that. So we have a little server now. So this needs to happen inside of that. Dot listen, let's give it a fixed port, 8080. So now whenever a request comes in, we're creating some HTML, CSS, JavaScript. You know what? I'm not going to type this out. I'm just going to show you the result. The idea is that you create a HTTP server here. And here you just pipe to fs.create file or fs.create write stream. So I can show you that. Build. I have a little folder called cheat in case I like need to cheat with y'all. So the resulting code looks like this. We have a start function. We have a build function. Here we create a server and we split based on request.url. So if a normal request comes in, we serve HTML up. If some other request comes in, like bundle.js, we serve up the JS, and else we serve up a 404. And then on the build side of things, the little build command is we create a directory called dist, and then we create some HTML that we write to index.html, and we pipe browserify to bundle.js. So that kind of looks like cheat build.js start. So it says, hey, listening on port 1337, curl localhost. It just does that. Bundle.js does that. But if we say this, build, it starts building. And then we get like these two neat little files there. Yeah, that's basically a build process. There's people that are like, oh, we really need like these frameworks like Grunt and Gulp, and I think that Node Core and a few little dependencies can get you really far away. Although, yep, so we've used browserify, sheetify, create HTML. What we didn't do is we didn't create static render pages, so we didn't like pre-compile all this HTML stuff. We didn't extract CSS to a separate file. We didn't run stuff like Uglify.js. We didn't like do anything fancy, and no assets. But if you do want that, use Bunkai. Module emit, yay! npm install Bunkai and you're done. Servers. Let's write a server. I'm pretty good on time. I might actually make it. So let's see. What do we want from a server? So a server should validate incoming requests, save incoming requests to database, do some logging, do some routing. Nothing much. The base idea of the framework we're going to be writing is we can statically validate our environment variables. So if these variables are not set for any reason, if we're missing port anywhere, then it defaults to 1337. And if it just makes sure we always set that value because it's important for us to run here. So then we like have app.route get. So we handle gets for this partial, and then we do some stuff with it. The example I like have lying around persist stuff to a database, but whatevs. Cool. So if you're going to be running a framework, probably the the framework of the framework itself is going to be a prototype function. Because generally what you want to have is you have two constraints. You want to have methods on your thing, and you want your thing to work really, really fast. If you're going to be calling methods over and over and over again, which you might be doing when you write a framework, you want to be using prototypes because closures are not really fast everywhere, and these give you like very concise stack traces. They like very reliable. So there's this little pattern you might like want to know about. That is, this allows you to do var foo is framework and just call it as a function instead of always needing to use the new keyword, because this itself calls a new instance of itself if it is not an instance. Kind of fancy, but if you see this in the wild, it's just a common JavaScript pattern, I guess. Why not use classes? Classes don't work everywhere, so don't use classes and modules. That's the gist of it. Like application level stuff, fine, but frameworks, no. Cool. So, do I want to spend more time on this? Oh, no, I don't. Okay, so this little module is kind of cool. I just talked about it. So let's create a little server file. Touch server.js, server.js, var ser. You know what? Var env. Let's copy this example. Screw it. I might like want to demonstrate what this module does. So let's say we require always a port, and that port is a string. Then we use the string constructor, just the prototype of it here, and then we say node server.js, and it will be, oh hey, damn it, you didn't specify an environment variable called port. So now if we do this, but we say port is 8080, then everything fine, and it just like goes on well. So env make sure that your environment variables that you depend on are always set. Kind of useful. Next, little router. I wrote a router. It's not the best router, but it's kind of nice. It's called server router. It allows you to like specify a method and does some partial stuff if you like it. It doesn't do too bad in benchmarks. Used to be really fast, but then Matteo wrote a faster one, I believe. It's kind of okay. You can just pass it to HTTP create server and it like works. For logging, I don't know who of you knows Matteo, but Matteo is Italian. He lives not too far from here. He's like sitting right over there. But he wrote a cool. So he's the guy that's not disappearing right now. So he's like really into performance, and he's like written these really cool like server framework things. And I've done like an attempt at most of these things, but then he like comes along and he does a better version. So I'm just like gonna be like telling you about some of his modules. Probably the biggest one is Pinot. It's a logging module. It's really, really fast. It has namespaces. Oh, hey there, camera. And you can, the coolest thing about it, I think, one of the coolest, least used features is you can create child loggers. So when you're like running very big production systems, you probably want to like know a client request happens. It hits a server. It goes through Nginx. It then hits like a service. It does a thing. And you probably want to log out at every point within that thing what's going on, like debug logs, like tracing. With Pinot, you can create a child logger for every request that comes in, and you give it a unique UUID, and that UUID will like show up in every time that the logger is called. So every time childlogger.info is called, or whatever method on it, it will also have the UUID property on it. This outputs a new line delimited JSON, by the way. So you just see like a long string, but makes it very easy to trace all your requests. And just like built into the fastest logger available on NPM. So, you know, it's kind of nice. Sure. Disconnect. Great. Oh, maybe. No, I'll drink some water. Thank you. Yeah. So I had someone staying at my house that had like a throat infection. I've been like throat things. Is it better? So how's your day? How was lunch? Did you have like a good time? I kind of like the pasta. It's like in Berlin we don't have great pasta. Is it? Just tell me when it's good. Sweet. I'm actually ahead of schedule. It's amazing. Um, so I was talking about like these child loggers, which is like very cool. So the way if you were like writing your own framework and you were to set this up like a plain HTTP framework, right? Then you would like create the router, like an instance of the router here. Uh, and then you would create something like, oh, an instance of the logger here. Oh, you should actually give it a name. And then some UUID counter there, or like have a way to extract UUIDs from headers or something like that. And then every time your router handles a request, you would create a new context log child. Oh, did I mess this up? Yeah, I think I messed it up. Wait, let me pull up the actual example because I have this working. Cheat/server. So app routes db get. No, this application code. Oh no, actually that was the good code. Sorry, my bad. So you create a what? No, what? No, no. Okay, here it is. So it's a context.log. You create a new object that you pass along. It's a common pattern in Go. Request, response, context, where you like set all these values on, so you don't have to overload either request or response. And then you just give it a new method called log, which you can use for logging for the whole request, because request and response are usually passed everywhere, and so would context. So now you can call context.log anywhere in your application, and it will have the correct trace. So you can trace your whole thing. And you can set this up like in 3 lines. It's kind of nice. That's the thing. Actually, let me show you what that looks like. So you like have a bit of an idea what the result of this looks like. So if we say node cheat app, no, server.js, then it outputs some new line JSON. And then we say curl, no, that won't work. Curl local host 1337, yes, /foo. Oh, damn it. I didn't handle the 404 handler. What routes do I have? Server. I have get. Cool. Cheat server. Oh, so I don't have /foo. I just have /get. Then, like, you can see ID 1, ID 0, ID 2. So increments every time. And all the logs within that request will like have that specific ID on it, which is, oh, whoops, which is like, you know, kind of cool. But you might be like, this is not useful for development. So you can like pass into Pina Colada, which is, if you like pretty logs, la 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 la, la la, la la la, Tmux, I don't know. Sorry, I can't sing. But yeah, this is like a pretty printer for the same logs above. So it just shows you like a smaller version of that. Yes. Okay. Okay. So framework HTTP logging. Yep. Oh, so framework HTTP. So we want to add a listen method. Did I show what it looked like? So back to what it looks like. Here, we have a listen method that we like pass a port, and then our application starts listening. We already just did the route method. We already did the env thing. So HTTP, little listen method. So it's still in our framework. Framework.prototype.listen. It takes a port, and then it creates an instance of HTTP create server. It passes it the router, and then it says server.listen, and just echoes out like, hey, I'm now listening on port. Pretty straightforward, not too different from the very first example. So in our code, I'm not going to type it out again. Kind of feel like typing it out. Oh, this is true, sorry. Where's our code? Yeah, so this is just a listen code. It's nothing much. Cool. So next step, creating a database. I'm a big fan of LevelDB. If you like need a quick database to just store some values in, then you can't beat LevelDB. Perhaps if you use SQLite, that might be the easier. It kind of depends on what you're used to. It has 2 methods, so you like create a new instance, as with all things, and then it has a put method, which allows you to like add a new value, and has a get method, which allows you to get the value for that key. Also has a del method to delete a thing. Those are like the most common ones, and it just gives you like either back a value or like an error. It's just, you know, standard Node stuff. Yeah, that's about it. So far we've used the nvob, Pinot server router, and I guess memdb packages. What we're not doing is consistent error handling, handling unknown routes. Let me actually show you some more of this. So node cheat server.js. We're going to do curl-x post. Is it post? Let me check. Post, indeed. Localhost 1337/kangaroo. Fine. Then we do that. So value set to kangaroo. And then we do curl localhost 7 values kangaroo. And now we change kangaroo to Mateo. We get it out. Enter that. We have a Mateo. Not so jumpy, but you know, it's fine. It'll do. Yeah, so that's the base of it. In our application logic, we do app.route post, takes the value, reads out context of params, which is the value we do here. So it has the same name, right? And then we log out a little bit of stuff, and then we like add it to a database. And on the read side, we do a database.get, and we just echo out the value. You can get way more complicated with like dynamic queries and validation and all that stuff. And you know, we're not gonna do that now because we have a time limit, and we're on framework number 2 already. Yay! So yeah, if you want to get like something like this, we're rewriting this right now. But yep, Mary is basically this. Very simple, very easy. Shouldn't like offer you too much over HTTP. Just a few conventions, right? Yeah, front-end framework. Now this is what people generally know me from. I have like a front-end framework. It's called Chew. It's very small. It's kind of efficient. So let's build it. Many people, they look at front-end these days and they're like, oh my God, it's so complicated. There's so many things going on. And then you might be like, well, it seems like it. There's large frameworks and lots of new words and concepts. I'm more of a Node kind of person. I'm used to like the Node APIs and like having few words generally. So kind of like been iterating on this one framework over the last year or so, I guess. But it allows you, instead of like creating new language features, it uses this ES6 Tag Template Strings, which is basically a new like strings that you can spread out over multiple lines and put values in. And we use this to create new DOM elements because it kind of looks like you're writing HTML, and everyone kind of knows HTML. So being able to like write HTML is quite nice in your app. So that's our HTML side. Then usually in applications you have state, and you need to manage state, and people have like all sorts of solutions for it. This is my solution. I use an object. And if you like want to modify the state, you add or remove a value from the object. It's quite efficient. Now you should see my stack traces. They're really nice. So yeah, moving on. To communicate like between your views and your state, you want to have an event emitter. Node has a built-in event emitter. I built one that has a very similar API, but slightly tweaked for browser usage. So same API, removed the methods you actually never use, and added a little bit of logging in it because it's kind of useful. Well, not console log debugging, but I mean performance.mark performance measure tracing, which is cool. I'll show you the demo in a bit. And it has like, if you want to create a listener, you say .on event name. If you want to emit a thing, you say emit event name with possibly some data, if you like. That's our whole talk thing. It's comparable to Redux and MobX, but in what it does. You can think of it the same way, but it's just rather minimal, I think. Oh, this is the part where I kind of like stopped writing slides, I guess. I missed this one. Yeah, no, I wrote this, when was it? 40 minutes ago. Um, right, so this router is kind of similar to the other router we already saw. It's like not rocket science. You have .route, so you create a new instance, and then you call .route on it, and then you have like a route, and then, yeah, that's the gist of it. Then for the fun part, many of you might like know React, which does this thing where it takes a tree of DOM nodes, virtual DOM nodes, and takes another existing tree of virtual DOM nodes and then applies, this is what I want it to look like on the existing things, and does it rather efficiently. But they use not real DOM nodes, but virtual nodes, which are like objects, and they're a bit magic-y, and they have their own things for it. I have an algorithm that operates on real DOM nodes, which is like kind of nice. So you can create like, say jQuery returns like a widget or something, and you like want to add it to your DOM tree, then you can use that widget, and then you can apply it to the actual existing DOM without any conflicts. And that's like kind of nice. So it just operates on normal DOM nodes. It works with like any framework out there that uses real DOM nodes. And it's also kind of fast, which is fun. So nanomorph. Nope. Nope. This one's mine. Nope. I'm sorry. Gonna take a quick sip of more. So, DOM diffing. Next concept, tracing. This one's really fun. This is a wrapper for performance mark and measure, which allows you to, hold on, we're just gonna debug my slides. So this itself is a Chew app, which is the higher level framework. I'm just explaining how it's built up and how you can like write your own, because that's fun. But this is the Chrome profiler. Let's say we like go from this slide to the next slide and back. Then you might be like, you might have seen this one before. I'm actually really proud of this. So these are your traces, right? You're like looking at your traces and you're like, oh no, I removed some of the, oh, I was having bugs. That's right. Okay, so the main idea is, do I want to, okay, I'm going to live super dangerously. Hold on. npm link, Chew. This might break my slides because it's a dev mode. Let's reload this. La, DOM diffing. Cool, do we have more traces now? We do. Do we? Do we actually? Do we? Yes. Yes. So for example, we have a start method and like shows up in the thing, and then you like have a render method and some more stuff. And you can exactly see all the stuff that is going on in your application. And that is using this API, nano timing, which is on NPM. And you just create a new timing, and then you say timing start, timing end, give it a unique UUID, so that these line up even if you're like running them asynchronously, and then you get like these super sweet traces. Damn it, did it clear? That's not fun. Let's go back. I want to show you like these ones. This is like so much fun. So for example, here we have a render call because we just changed the thing. And then on the left, there's it says the route we just called. And on the right, it says how long it took to like update the whole page. And if anything is ever slow, you can just like look into these logs and be like, oh, it's, this is why it's slow. Or this event calls like heaps of stuff. So, we should debug this. I don't see people do this a lot in front-end framework stuff. In serverland, they do lots of tracing. Front-end, not so much. But it's kind of nice what you can do. Okay, last one. I think last one. Yeah. Requestanimationframe. So say, because I might not have explained this properly, but with this nanomorph thing, DOM diffing, nanomorph. What you do is you create a new tree of elements based off state. So the idea is you create a function and you give it some state, and then you create like a new tree of elements, and then you apply that the way things should look like. You tell this algorithm, make the existing DOM look like this. And that's a rather expensive operation. So people can't really see more than 60 frames a second. So what you want to do is make sure that this doesn't happen more than 60 times a second. Because else, if you have like 100 updates in 1 second, then your whole application starts to crash and it really sucks. So that's what this thing is for, Requestanimationframe. It just checks if it's available or not, and then like uses it, I believe. Yeah, that's it. I can show you like the little framework I built. Let's go to app.js, cheat app.js, I think. Yay. So again, like with the first framework, I'm too lazy to type it out at this point. I'm so sorry. But we create like a new framework. We give it 2 methods, the route method, 3 methods, the use method, and the start method. I should maybe like walk through this. Damn it. How much time do I have? I have like 10 minutes left. I think I'm supposed to like stop soonish. Anyway, this is 50 lines of code. I'll put this online. You can read it after. This is 50 lines of code, including like the using of this thing. So if I run this thing, Bunkai, cheat, app.js, 80, 81. I can't autocomplete, I'm sorry. And we go here, here. Then it says little hello Verona, which is the code. The usage of the framework looks like this. You say create a new instance, app.route on slash, oh, not that, return some HTML, and then you hit start. And then what we could do, for example, here, is create a little button with some text. And then if we want to have like an on-click handler, we can do like on-click is on-click or something. And then here we do function on-click console.log hey there, or something like that, right? So now we've changed this to that, and now we click this, and if we hit our thing, then it says hey there right there. We click it again, yay, right? So yeah, this is the way you would write like HTML. I don't have like time to like explain this whole thing. I explained the modules we're using inside of it. This is just a little bit of glue code to like combine it. So we like create a new little instance there of all these things. Again, our little state is just an object, and we mutate it. We have a way of creating like little functions that we pass some stuff into, and a little start method that does the 60 FPS stuff and diffs the existing DOM with like the new version efficiently. And that's the whole thing. That's the whole app. Yes, there. So these are packages we used. I think I explained all of them. Yes, I did. Okay, that was my talk. Thank you.